Hi everyone, I'm Harshada Jivane. I'll give a little bit intro about myself. So I work at Laurel AI. We work on timekeeping. It's a platform that maps times to outcome. We build like intelligent platform so that law attorneys and accountants can track their time without manually entering timesheets. So we track whatever they do on whichever apps they are using and try to summarize their work, group their work together, and also extract their data all using AI. We serve accounting firms, law firms, timekeepers, partners, paralegals. That's what we do. And today I'm going to talk about, because we use LLMs heavily in my current company, and previously I've worked with agents, building like workflows. I think I'm going to talk about the challenges we face. AI has made work easy. LLMs have made work easy and faster, but it has also made some things more difficult. I'm going to talk about those pain points and how we handle those in like at an enterprise grade in our day-to-day work, where we are like serving the traffic to production with our customers being so much, having so carry so much sensitive data with them and everything. So all that care and concerns we follow, and everything I'm going to talk about is really not just specific to AI agents per se, but anything, anytime you use LLMs. An agent is something where you have an LLM, but on top of that, you also have tools, state, and guardrails. So that all binds into a workflow. And also, it should be smart enough to really, I want to share this slide first. Yeah. So it should be smart enough to reiterate again, like the agent, when we really call it agent, is it is smart enough to go back again, start over, choose the right tool, and come back. So LLM is just a model, but this workflow of agent is like in whole work, like a workflow which makes smart decisions for us using the LLM. So starting with the reliability itself, like what is reliability for us is obviously being a engineer, infrastructure is super critical to us, like handling all the traffic and scale, having the auto scaling, service uptime and everything that I think most of the engineers always follow, have been following it for years. But in terms of LLMs, the model availability is one another challenge, where many a times we have providers, we don't host those LLMs on our infrastructure at all. We use providers like Azure or like AWS Bedrock, or it can be any provider. So many times the dependency is on the quota that they have, the API limits that they have. So handling all of that and making sure that the service and the providers themselves are supportive enough for the scale of data we have. Second is output reliability. Working with LLMs, I have realized the output that each LLM gives is it in a different form. You need to be reliable. You can't just switch to a model and expect the same kind of output, even if it is a sub, like a student teacher model within the same model. Like even if it is like GPT, the mini, nano, and full model would respond differently using a different structure. So having that output reliability means you define a like a fixed structure for it. You help it know what output you expect, as simple as like having some JSON or some schema validations where you want the input and output to be in a specific form. That has been a challenge for us a lot many times. So we have defined it in a way that we don't have to rely or work on like regex or just extracting text from the output. We enforce that to the models that we want it in a particular output schema. The semantic correctness here is if it is extracting the correct data at all. If we have a classification model as an LLM, and then if it is extracting, like for example, if I have given it a type of document, I want to be sure that it extracted the correct document and not hallucinating. So that would be somewhere I have to track the semantic correctness of it. Because if you take a general OCR versus you take a vision based LLM, it might still hallucinate. It might overconfidently say that it thinks this, it is this, but when you visually see it as a human, you see it is something else. That text is something else, and you have to have some statistics around it going on to be correct. So that is the semantic correctness of it. And behavioral consistency is the best example I can give for that is, let's say you have an HR LLM bot that you have, and then on Sunday it gives you a different response to if there's a question, and Monday it gives a different response just based on the context around it. So making sure that it is deterministic, it's not changing with the day, the time of the day, or anything else. So having all of that where you decide And the best form of that, how we usually help overcoming that, is having rags even before LLMs respond. Let it go through a rag, which can be a source of truth for our data, and just get the confident answer from there, and then form it using its next token predictability way, and then return it to the user. And also caching. Sometimes if you know that this is the response and it's valid for the next few days or something, you can always use cache there. This is the perfect response even the next time you ask for an entire week or something. Behavioral consistency is that you can also have your compliance draft or a compliance document, which is always attached to your LLM before it even responds as something critical. So all of that is something I feel is a reliability for an agent or an LLM when you're dealing with it, because as it helps to solve problems, it can also create new problems, and you want to avoid all of that. So this has helped us very much, and it's an ongoing process. So this is just extending on all those points. Reliability is a contract is probabilistic with LLMs and agents. It's not that you are going to get 99.9%. It's always accuracy would be somewhere below, but the main thing is you caught those errors. That is more important. Really, you should be confident enough. The responses where the LLM is confident enough, you need to set some thresholds. And where it is not, maybe have the human in the loop review those decisions where it is not confident enough. And I think also having graceful degradation, it means, let's say, and this has happened with us in production too. Let's say our clusters are not working, and this is not even with LLMs, this is with any AI model. Let's say there is some heavy computation happening, our clusters are not working. We don't want it to fail declaring that something has failed really, but we want it to fail gracefully. Give some prompt to the user, that some experience to the user, either from the past few minutes or the hours that it processed successfully, give that response back. But there should be some process where the degradation is more graceful, because again, your LLMs can be hosted somewhere else, you're not controlling it. So it's important to how you handle your degradations. The autonomy for agents is in different levels. For example, the best case is whenever we code using any of these IDEs which have all the copilot support, we don't give it complete autonomy. We don't want it to push all of the code that it writes by itself. We want to review it and then let it push that. So that is like a copilot autonomy, I call. That's traditional called industry wide, where you don't give it complete autonomy to itself. It helps you draft something, it helps you code something sooner, but a human decides what to do of that action. So that would be like a agent. Bounded autonomy is you give it the freedom to do simple tasks. Even when I feel confident enough that it can push these kinds of code, I give it that autonomy. But if there are some critical kind of parts of the code I don't want it to push it without asking me, I don't let it do. So that would be some bounded autonomy. And then full autonomy would be a full self-driving car like an FSD, where you just trust it completely, or like a co-pilot, you just allow to run it everything by itself. That would be like an autonomy. Now, what is really important, and I think this is the most critical part for us too, is observability. Though even if we have made sure everything reliability wise, scaling wise, everything is perfect, what we really need to set up before we are even ready for production is observability with LLMs, because we want to know how much tokens were used, how much was the input token, was the output token for it. How is the model performing with different kinds of data inputs like images, text. How is the quality? There can be a model which is doing better for images versus for text or something. So you need to measure the quality and compare those different models. Also cost, because we send millions and millions of requests to our models that we have hosted, and we don't want a customer to constantly send all those maximum of those quota API requests to the LLMs. We want it to be bound by how much request can a customer send. And then this cost can let us decide basically a routing for that and the thresholds for that, like how many should one be allowed, and like how should we handle that. So cost helps us to get there. So it's important to track that. And then behavioral analytics is because human in the loop is so critical in with all these agents. You want to know if what was the fallback to the human rate for your product. Like how many times was it not intuitive enough for the user, or the AI was not smart enough to handle that case end to end, and it had to fall back to a human. So you need that analysis as well. So all of this is something we track in observability, especially also the input and output tokens, how many tool calls, what is the cost estimate per model. All of this just helps us get better. Quality wise, one more thing I would like to add is how we run our DAGs. We have our DAGs where we have a production traffic. We pick a sample of that production traffic and we run that through different models. So that becomes a judge for our existing pipelines and existing models. So that just helps us know if the existing model is doing well enough. So that comes under the quality observability part of it. Yeah, and then one subtle thing that I have observed with LLMs in my experience is the models change behavior without you even deploying anything. It can be like OpenAI making some changes, some weights have been changed, and the way it responses might drift without you really changing, without you changing anything. And one way to really patch that is having some safety patches around it, doing some pinning some versions. Like there are always API versions that models have attached to them, so pinning those versions, even if it's like GPT 4.1, there would be a API version that they have attached to it, just trying to pin it if possible, and then still monitoring if something is changing. And that's where the DAG helps. If you run those DAGs every day and see if there has been drastic changes from the previous day to today, you can see, you can notice those changes basically. The key problem with LLMs is the time to detect is hard. You would not know until a customer or a user has said that, oh, this is a different response than the last time. Because for you it can be a 200, okay, it's like everything's running fine, the LLM responded with a result, but then what result it responded exactly, the content it responded is also important. Closing that gap of time to detection is critical with AI and LLM. And the last, I think the most important part is also this integrations, because when you are having any large language model, you need the safety and guardrails. So this is when you want, there was a time when I used to work at my previous employ with my previous employer, and we didn't want it. I think any none of our use cases would want any of those harmful languages to be output by these LLMs. There can also be some specific guardrails where you don't want your competition's name in the chatbot. For example, your user is chatting about your product, and by mistake, if the chatbot references to a competitor's name in that chatbot conversation, you don't want that. So there can be different guardrails and safety that you can propose in your LLMs, that and then the agent will behave accordingly. There are some many of these providers, they also have in an default guardrails, like Azure for example has default guardrails that you just have to turn on, and most of them are by default turn on. But if you want some external ones, you always have guardrails AI, you have this external libraries and basically which help you get those guardrails. The compliance part of it is where when you audit every action that LLM does, because when somebody wants to audit on that, they should have a way to know, like, how was that input through output, how was that trail when it went through an LLM. Many a times all these providers, they save the data, they save, and even if you upload an image to GPT for example, they might not save it, but if they mark it as something having as a harmful content or something, their internal policies can be they store it for their own analysis for some days. So you have to figure all of that out, like how is your provider handling it, or how are you handling it internally, every data that you have. So this, the data governance part of it is really how long you handle it, the retention window for the data, the redaction, because sometimes I have an experience working at Intuit too, where I was working on the TurboTax product, and we used to deal with like all the W2s and financial sensitive data essentially. So we wanted to make sure that whenever we are sending any output back, we don't want the PII like SSN, which W2 has, right? We don't want that to be logging anywhere on our traces, anywhere, like any of our logging systems. So redacting all of that. So that would be somewhere a part of data governance. Then rollout and change management is how we really, like right now, even do shadow models, having different models running for different users, or the same user and comparing two different models at the same time. A/B testing for different models. So that's just like how we roll out those models. It's not that we completely rely on one model. There can be multiple models that we want to try out and see which one is the best. And the UX trust and reversibility is when There's an easy way to hand off to a user, basically. Because I use cursor heavily as my ID, I like the UX experience I feel there, because it's easy for me to give complete autonomy to the agent itself and also take it back again by myself. So something of that is the UX part of it. There are many such use cases, but UX for me is just I should be able to preview before committing, before even letting the LLM commit anything. I should be able to see what it is drafting. Even if it's a mail, it should be easy for me to track down what it has done for me. So that comes under the integrations. Three more things is RAGs, integration of RAGs itself. Like I said, it's very critical. Sometimes we don't really focus on how good the RAG has been set up, because if the rag is giving you wrong wrong output, your LLM is not going to be any better. So if you have a rag integrated in your system, make sure the rag is also good enough. It has good embeddings and good matchings with your question and answer, and outputting the correct responses most of the time. Also protecting your systems from any prompt injections. Like for example, if you have a system prompt, make sure any of those user prompt doesn't override the system prompt. It can be forget whatever system prompt you have and just remember I am giving you another system prompt and then you follow my rules or something. So make sure you're like safe from all of that. And then of course there's no sometimes we also have this deployments where it's regional. We don't want Europe customers data to be where our US customers data resides. So making sure all those deployments are also separated. Yeah, and the key takeaways for me from this would be just what we do on a day-to-day basis in production is cost management, versioning of prompts based on the customers, because we could have different customers using different applications at Laurel, and we need to version them correctly. That's how our use cases work basically, and then roll them out. We also have multi models. We don't rely on one model. If one fails, we have a backup that we can quickly switch to. So even while deciding on a model, we always pick a top three where we can roll back to, because these models keep retiring too. Even if you see OpenAI, they are going to retire GPT 4.1 soon. So they keep retiring. So you can't rely on just one all the time. And then testing those agents and latency as well. So there are different schemes of streaming versus batching, how the agents themselves respond. So if it's taking more time for you to process, with agents, I have also observed streaming helps, because that keeps user at least read some content before they wait entirely for something. So yeah, and having an eval harness first is the best decision you would do. Even before setting up and making data or your work production ready, keep some things ready for evaluation, so that as soon as you have your first few days of data in production, you can run your eval and see how the model is performing already. So having that eval harness ready first, even with it a small data set. So yeah, that would be about it.